Good day everyone! Welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving linear inequalities. So here are the steps in solving linear inequalities. So first step is to draw the graph of your equation. Now please take note of the following. When we encounter the inequality symbol greater than or less than symbol, we plot using an open circle and we connect the points using a dashed line. Now, if we encounter a greater than or equal or a less than or equal symbol, we're going to use a closed circle in plotting the points and we connect them with a solid line. So, second step is to check which side of the graph will satisfy the inequality. So, we're going to use a testing point and substitute it to our original inequality and see if it satisfies or not. Third step is to shade the side that satisfy our inequality. Now, let's have some examples in solving linear inequalities. Alright, okay, let's have an example. So, for example, we have x plus 2y is greater than 4. So, first step is for us to graph x plus 2y is equal to 4. So, we will change the inequality symbol to an equal symbol. Okay, so we graph using the intercept method. Let's solve for our x-intercept and y-intercept. So, let's solve for our x-intercept. We replace y with 0, solve for the value of x, x is equal to 4. So our x-intercept will be located at 4, 0. So in this case, we're going to use an open circle because our inequality symbol is greater than. Okay, next, let's have our y-intercept. So let's solve for the y-intercept of this graph by replacing x by 0. Okay, let's solve for the value of y, divide both sides by 2. Y is equal to 2. So our y-intercept will be located at 0, 2. Now let's connect the points using a broken line or a dashed line, knowing that all the points along this line will not be part of our solution. Okay, that's why it is a broken line. So now, next step, our graph is divided into two regions, the upper part and the lower part. Now, to solve our inequality, okay, we need to assign a testing point. We can give any coordinate along the decision plane, okay, for example, 0, 0, and we're going to test this coordinate by substituting it to our original inequality. If it satisfies our inequality, we will shade the region where the testing point is located. If the testing point did not satisfy our linear inequality, we will shade the other side of our graph. So in this case, let's substitute 0, 0 to our inequality. Simplify, we will have 0 is greater than 4. So it did not satisfy our inequality. Therefore, we are going to shade the upper portion of our inequality, meaning that all coordinates in the upper part of that graph will be a solution to our inequality. Alright, okay, let's have another example. So for example, we have 3x minus 2y is less than negative 6. So first step is we need to graph 3x minus 2y is equal to negative 6. So we will just change the less than symbol to an equal symbol. Then we start graphing. So let's use the intercept method in graphing a linear equation. So let's get the x and y intercept. So let's solve for the x-intercept by changing the y, the variable y, to 0. Let's solve for the value of x. We will have 3x is equal to negative 6. Divide both sides by 3. X is equal to negative 2. So our x-intercept will be located at negative 2, 0. Ayan, we will use an open circle in plotting our points because our inequality symbol is less than. Okay, let's solve for our y-intercept. So let's solve for our y-intercept by changing our x variable to 0. So simplify, we have negative 2y is equal to negative 6. Then, we divide both sides by negative 2. So y is equal to 3. Our y-intercept is located at 0, 3. So that will be our y-intercept. Now let's connect the points using a dotted line or a dashed line. So that is the graph of our equation. Now let's proceed to our next step, which is we're going to assign a testing point. Now the best testing point is the coordinate 0, 0. Let's use 0, 0 as our testing point. Now if our testing point satisfy our inequality, we will shade the area where the testing point is located. Now if it did not satisfy our inequality, we will shade the other area where our testing point is not located. Okay, so let's substitute our testing point to our inequality. So changing the values of x and y, then simplifying, we have 0 is less than negative 6. So it did not satisfy our inequality, therefore we will shade the other side of the graph. So we will have, the solution of this inequality will be found in this side of our graph. Alright. Okay, let's have another example. So for example, we're given y is greater than or equal to 2/3 x minus 4. So first step is for us to graph y is equal to 2/3 x minus 4. So in graphing this slope-intercept form, we can use the slope-intercept method. So we get the slope, which is 2/3, and we get the y-intercept, which is negative 4. So first is we plot our y-intercept. So let's plot negative 4 in our y-axis. So it is located here. So take note that we use a closed circle. Take note that we used a closed circle because our inequality symbol is greater than or equal. So next, let's identify the next point using our slope. So let's count the number of rise and run. So 2 units up and 3 units to the right. Okay, so that will be the location of our next point. So let's connect the 2 points using a solid line. That will be the graph of y is equal to 2/3 x minus 4. We're not yet done. Let's identify which side are we going to shade. So let's use a testing point. And for our testing point, we will use the coordinate 0, 0. Let's substitute our testing point to our original inequality. So let's see if it will satisfy the inequality. So substitute, simplify, we will have 0 is greater than or equal to negative 4. So it satisfies our inequality. So we will highlight or shade the area or the region where 0, 0 is located. So this shaded region means that all the points, all the coordinates that is part of this region will satisfy our inequality. Alright, okay, let's have our last example for today. For example, we're given y is less than or equal to negative 2/5 x minus 1. So first step is for us to graph y is equal to negative 2/5 x minus 1. We just change our inequality symbol to an equal symbol so that we can graph our equation. So in graphing this equation, we will use the slope-intercept method. Let's get the slope and the y-intercept of this linear equation. Okay, so our slope is negative 2/5 and our y-intercept is negative 1. So let's plot first our y-intercept, negative 1. It is located here. So if you can observe, we used a closed circle in plotting this point because our inequality symbol is less than or equal. Next is we're going to use the slope in identifying our next coordinate or the next point. So we have negative 2, so 2 units down and 5 units to the right. So 1, 2, 3, 4, 5. So our next coordinate will be located at 5, negative 3. And let's connect the 2 points using a solid line. Now our graph is divided into 2 regions, the upper part and the lower part. Now to identify the solution, we will have or we will assign a testing point. So let our testing point be equal to 0, 0. So our origin will serve as our testing point, and let's see if our testing point will satisfy our inequality. So if it satisfies our inequality, we will shade the region where our testing point is located. If it did not satisfy our inequality, we will shade the other region. Let's substitute. 0, 0 to our original inequality. Let's simplify. We will end up with 0 is less than or equal to negative 1. It did not satisfy our inequality, therefore we will shade the lower part of our graph. So this yellow line will serve us all the coordinates that are possible solutions to our inequality. Alright, now that you already know how to solve linear inequalities, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!